Forget everything you know about crocodiles. During the Eocene epoch, 56 to 34 million years ago, one crocodile broke all the rules. This was Boverisuchus, a terrifying land-based killing machine that completely abandoned the water. It wasn't your typical swamp-dwelling predator, but a creature with long, powerful legs, hoof-like toes, and a rounded tail, all designed for running and hunting prey across the ancient forests and arid plains of Europe and North America. The Eocene epoch was a time when Earth's ecosystems pushed evolutionary boundaries in ways that seem almost impossible today. During this remarkable period, crocodiles embarked on what we might call the Great Crocodile Revolution. While their modern descendants perfected aquatic hunting, ancient crocodile lineages pushed into entirely different ecological niches. Boverisuchus belonged to a group called Cebacids crocodiles that are interpreted as having abandoned water altogether and become specialized terrestrial predators. These weren't just crocodiles that occasionally ventured onto land. Fossil evidence suggests they were fully committed land dwellers that had evolved away from aquatic life entirely. During this time, the crocodile family tree looked radically different from what we see today. Traditional semi-aquatic crocodiles shared the planet with their land-based cousins, creating a world where crocodilian predators dominated both environments. The Cebacids represented one of evolution's boldest experiments, transforming the basic crocodile body plan into something suited for high-speed pursuit hunting on dry ground. Their skulls developed deep, narrow profiles that housed powerful jaw muscles, while their teeth evolved into blade-like structures designed for slicing rather than gripping. The Eocene was warmer than today, creating widespread warm forests and environments where terrestrial predators could thrive. These environments offered abundant prey, but required different hunting strategies than aquatic habitats. Traditional crocodile ambush tactics wouldn't work in open woodlands, where prey could spot predators from a distance. Success demanded speed, agility, and the ability to pursue fleeing animals across varied terrain. Cebacids appear to have responded to these challenges by developing anatomical features that modern crocodiles lack entirely. Their leg bones became longer and more robust, supporting bodies built for sustained running rather than explosive lunges from water. Their spines appear to have developed differently, interpreted as adaptations that could handle the stresses of terrestrial locomotion. Even their tails transformed, losing the laterally compressed shape that helps modern crocodiles swim, and developing rounded profiles better suited for balance during land-based pursuits. Fossil evidence shows substantial changes in the Cebacid body plan that over evolutionary time produced a form well suited to life on land. The Cebacids proved that crocodilian body plans could support apex predator lifestyles in terrestrial ecosystems, challenging everything we might assume about crocodile evolution. Boverisuchus stood at the pinnacle of this evolutionary experiment, and examining its anatomy reveals just how perfectly adapted it became for terrestrial hunting. Every aspect of Boverisuchus' anatomy was built for terrestrial predation. Estimated at roughly 7.2 to 11.8 feet long, its legs stretched much longer than any modern crocodile, creating a body profile that looked more like a massive monitor lizard than the squat, water-adapted reptiles we know today. These elongated limbs positioned the animal's belly well above the ground, allowing for efficient overland travel without the belly dragging locomotion that characterizes contemporary crocodiles. Skeletal proportions suggest weight-bearing adaptations for sustained terrestrial locomotion. The feet present perhaps the most striking departure from typical crocodilian anatomy. Instead of webbed digits designed for swimming, Boverisuchus developed toes that functioned more like primitive hooves. These digits were shorter and more robust than those of aquatic species, with the claws appearing adapted for terrestrial traction and weight-bearing rather than swimming. Its tail architecture reveals another crucial adaptation. Modern crocodiles possess laterally flattened tails with prominent neural spines that create fin-like crests, perfect for aquatic propulsion. Boverisuchus abandoned this design, completely developing a rounded tail cross-section that provided better balance and coordination during terrestrial movement. The vertebrae show reduced neural spine height, creating a more flexible appendage that could act as a dynamic counterbalance while pursuing prey across uneven terrain. The skull construction emphasized power over the grappling abilities of aquatic crocodiles. Boverisuchus possessed a deep, narrow skull that housed tremendously powerful jaw-closing muscles. Skull shape indicates strong jaw musculature suited to slicing rather than simple gripping, generating bite forces optimized for different prey handling techniques than those used by contemporary crocodiles. Most importantly, the teeth evolved into precision-cutting instruments rather than the conical gripping pegs of aquatic hunters. Instead of the round conical teeth used for gripping in modern crocodiles, Boverisuchus had laterally compressed blade-like teeth interpreted to be better at slicing flesh. These dental arrangements created efficient meat processing tools for land-dwelling animals, representing a complete departure from the fish-catching dental patterns seen in water-adapted crocodilian species. This anatomical package created a predator perfectly suited for hunting in the dense, shadowy environments where it made its home. These forests of Eocene Europe and North America became the domain of one of evolution's most formidable experiments. Picture dense woodlands where towering trees created shadowy corridors, and Boverisuchus moved through these environments with deadly efficiency. Its powerful legs allowed navigation through fallen logs and dense undergrowth that would trap modern crocodiles. The forest floor provided ideal hunting grounds for an animal designed to pursue prey rather than wait for it. Early mammals and other ground-dwelling vertebrates, still relatively small and vulnerable, represented perfect targets for a predator that could chase them across varied terrain. Paleontologists interpret Boverisuchus as a pursuit-capable predator that likely employed sustained chase tactics completely different from contemporary crocodilian behavior. Instead of explosive lunges from concealment, this predator appears to have relied on active hunting strategies. Its elongated limbs suggest the ability to maintain speeds that would exhaust most prey animals of the time. Small herbivores and early ungulates found themselves facing an unprecedented threat, a crocodile that could pursue them like a mammalian predator, but with the crushing bite force of their aquatic relatives. Forest environments presented unique challenges that Boverisuchus handled through its specialized anatomy. Dense vegetation required precise maneuvering abilities, and its flexible body plan allowed navigation through tight spaces while maintaining pursuit capabilities. The hoof-like toes provided superior traction on leaf litter and soft forest soil, while the rounded tail served as a dynamic stabilizer during complex movements through woodland terrain. Prey animals faced an unprecedented threat in these ancient woodlands. Traditional escape strategies like climbing or hiding in dense vegetation proved less effective against a predator that combined crocodilian power with enhanced terrestrial mobility. The blade-like teeth could slice through hide and muscle with surgical precision, delivering wounds that prevented prey from escaping to heal. This hunting efficiency made Boverisuchus one of the most formidable predators in Eocene terrestrial ecosystems. This predator fundamentally altered how animals used forest shelter and escape strategies, eliminating traditional safe zones and bringing crocodilian lethality into environments where prey expected relative safety. Yet this remarkable evolutionary success story would not last forever, as changing conditions began to challenge these specialized adaptations. Most researchers think a combination of climate change and increased competition from evolving mammals likely contributed to their decline. As the Eocene epoch progressed toward the Oligocene, global temperatures began dropping significantly. The warm, humid forests that had supported diverse terrestrial ecosystems started fragmenting into smaller patches separated by cooler, drier landscapes. These climate changes reduced the prey base that Boverisuchus and other cebacids depended upon for survival. Competition intensified from an unexpected source. Early mammals were rapidly evolving their own sophisticated predatory forms. Primitive carnivorous mammals developed pursuit hunting strategies that proved more efficient than those of terrestrial crocodiles. These mammalian predators possessed several critical advantages over cebacids. Their metabolic systems allowed for sustained high-energy activities in cooler temperatures, while their smaller body sizes required less food to maintain viable populations during environmental stress periods. The cebacids faced a fundamental biological limitation that may have sealed their fate. Because reptiles depend on external temperatures to regulate activity, declining global temperatures during the late Eocene and Oligocene may have reduced their hunting efficiency relative to warm-blooded mammals. Mammalian competitors maintained consistent energy levels regardless of ambient temperature fluctuations, potentially giving them decisive advantages during cooler periods that became increasingly common. Changes in climate and habitat would have altered the available ecosystems, likely reducing the contiguous forested areas these predators used for hunting. These environmental changes required different hunting strategies and body plans than those perfected by terrestrial crocodiles. Meanwhile, semi-aquatic crocodilian lineages maintained access to stable river and lake ecosystems that provided consistent resources throughout climate transitions. By the end of the Eocene, approximately 34 million years ago, cebichids are no longer found in the fossil record in Europe and North America, leaving researchers to infer why this terrestrial experiment failed to persist. The surviving crocodilian lineages were those that had remained faithful to semi-aquatic lifestyles, proving that sometimes evolutionary conservatism succeeds where radical innovation fails. This remarkable chapter in reptilian evolution demonstrates just how dramatically life can transform when conditions allow for such extraordinary adaptations. Modern crocodiles, the dominant predators of river systems, are evidence of a different evolutionary path. While Boverisuchus and its cebichid relatives ventured onto land, the surviving crocodilian lineages were the ones that remained faithful to an aquatic lifestyle. The failure of the cebichids isn't a tragic evolutionary tale, but rather a profound lesson. The disappearance of these terrestrial predators shows that extreme specialization to a niche environment can be a double-edged sword. When conditions changed, the very traits that once provided an advantage became a burden. Meanwhile, the semi-aquatic crocodiles maintained their flexibility, surviving numerous climate shifts thanks to the stable resources offered by rivers and lakes. Boverisuchus is a powerful reminder that even animal groups we consider familiar can transform into completely different forms under the right evolutionary pressures. Its story demonstrates that life is full of bold experiments, but not every experiment is destined to last forever. Despite its incredible evolutionary history, Boverisuchus is largely absent from popular culture today. Unlike prehistoric superstars such as the T-Rex or Velociraptor, Boverisuchus rarely appears in blockbuster films, video games, or as a popular toy. This lack of presence is partly due to its form. Boverisuchus was a type of crocodile, a modern animal with which we are already familiar. This reduces the sense of novelty and alienness that often captivates audiences. However, Boverisuchus and its cebichid relatives are occasionally featured in scientific documentaries and specialized books. They serve as a prime example, used to illustrate extraordinary evolutionary diversity, shattering the stereotype that crocodiles are always slow, semi-aquatic predators. In these contexts, Boverisuchus is often presented as key evidence for just how wild and daring life's experiments have been. In short, Boverisuchus remains a character known primarily to paleontologists and enthusiasts. It was a spectacularly successful predator in its day, but in our world it remains one of evolution's lesser-told stories. Boverisuchus stands as one of evolution's most fascinating experiments, proving that even established body plans can transform into something completely unexpected. These terrestrial crocodiles dominated ancient forests for millions of years, developing hunting strategies that modern crocodiles never attempted. Their blade-like teeth, hoof-like toes, and pursuit-based hunting methods created apex predators perfectly adapted to life on land. What would you rather face, a modern crocodile in water or a fast-running crocodile on land? If this terrestrial crocodile surprised you, leave a comment telling us which prehistoric oddity you'd like explored next, and consider subscribing for more deep-time stories.